Welcome back to the deep dive. Today we are taking a really necessary look at how technology is reshaping conservation work. Specifically, these intelligent, small-scale AI applications, we're calling them micro apps. So
hmm
our mission today is to explore this real shift in conservation. I mean, for decades, effective fieldwork, proper ecological research, it required massive budgets.
Oh, absolutely. Heavy equipment, specialized software.
Right, stuff that demanded deep expertise. And now we're looking at a suite of tools that takes tasks that once took days or even weeks and just crunches them down to
It's
seconds.
really about the democratization of scientific power.
Democratization, that's a strong word.
It is. Because historically, conservation has been kind of paralyzed by two things, right? The cost and then the difficulty of processing all this messy, low-quality data you get from the field.
You mean like thousands of images or audio clips from a remote team?
Exactly that.
Yeah.
And what these micro apps do is instantly turn that mountain of raw, often unusable data into high-value, actionable scientific evidence. It makes conservation immediate and accessible for anyone.
So what you're saying is a dedicated high school citizen scientist out in, say, the remote Greek islands, they could run the same kind of analysis as a PhD student at a major university.
That is precisely the goal.
Mhm.
We're removing the barriers. Let's start with the most persistent challenge in fieldwork: data volume and quality.
Okay.
Anyone who's ever deployed camera tracks knows they're cheap, they're reliable, you can scale them up, but there's always a huge catch.
The image quality, especially at night.
The image quality. You end up with just thousands of photos that are, well, they're just unusable blurs.
And unusable evidence is just wasted time and money.
It is. And this is really where the AI steps in with what we call deep data enhancement. New AI models are being trained specifically to colorize and sharpen these low-light images.
So they don't just brighten the picture.
No, not at all. They actually rebuild the useful, defining features of the animal.
So if a camera trap gets a shadowy outline of a super rare mammal at 3 in the morning,
Yes,
the AI can turn that blurry mess into a clear, research-ready photograph?
absolutely. The models are highly specific, designed to maximize clarity. And this is just revolutionary for research in places that can't afford expensive gear.
So, poorer countries can now use basic hardware and still get high-res data.
Exactly.
Okay, I have to introduce some friction here. If the AI is essentially filling in details that the camera sensor missed, isn't there a risk of AI hallucination?
That's a great question.
Where the algorithm just makes things up and compromises the scientific rigor of the evidence?
A crucial question. And it comes down to transparency. The models are validated by conservation scientists, and they're trained on known data sets to suppress those kinds of artifacts.
So there are checks and balances.
There are.
Mhm.
And the core data, the time, the location, is cross-validated. The goal is clarity, not fabrication. It's especially vital for, say, monitoring the Mediterranean monk seal.
They live in those deep, dark caves, right?
Deep, lightless underwater caves.
Yeah.
Before you'd get a grainy blob. Now, you get scientific proof of presence. And that's essential for defining marine protected areas.
Wow. Okay, so that is transforming uncertainty into real clarity.
Is.
But these apps aren't just for heavy image processing. They're also streamlining simple day-to-day workflows and even legal compliance. Let's talk about the fish size app. It seems too basic at first, but its purpose is kind of genius.
That's brilliant.
It helps fishermen and conservation teams check the legal size of a species right there on the boat, just with their phone.
And the key is the immediacy of that regulatory check. For protecting coastal ecosystems, prevention is so much better than, enforcement after the damage is done.
Right.
This app scans the fish and instantly checks it against complex local Greek laws, which can change by region or even by the time of year.
So it tells them right away if it's legal or undersized or a protected species that has to go back.
Immediately, it puts the power of compliance right into the hands of the fishermen themselves. It fosters this culture of self-correction.
Which protects their livelihoods and the fish stocks. That's a win-win.
It is.
Okay, so that covers enforcement. But good data is the foundation of good policy. How do these tools help with the data management nightmare? I'm thinking of the file renamer tool. Anyone who's been in the field knows the pain of thousands of photos named img4702.jpg.
Oh, it's the single biggest cause of data projects failing. Messy archiving. Breakdown.
Yeah. So what does this tool do?
It's deceptively simple. You just upload the folder of photos you need sorted. Then you input three things: the scientific name, the observer's name, and the location.
And what if What if you're in a rush and you forget to log the location coordinates? It happens all the time.
Right, a super common field mistake.
Yeah.
And the app is, well, it's intelligent enough to handle that.
Oh, really?
Yeah, if you don't input a location manually, it just automatically grabs the latitude and longitude from the photos, the EXIF data.
Wait, ESIF, for our listeners, what is that?
It stands for Exchangeable Image File Format. It's that hidden metadata that your camera automatically embeds into every photo file.
The timestamp, shutter speed?
And most importantly for us, the GPS coordinates. The app just pulls it right out, so you never lose that vital spatial data.
That is an incredible detail.
And this is the part that saves months of work. The final file name format is highly structured, it looks like. Species name observer, name location date continuous number.
And why is that specific format so important?
Because that hierarchy makes the data automatically compatible with international biodiversity databases like GBIF. So it prevents data from getting stuck in a silo. It's cataloged and globally shareable before it even leaves your device.
Fantastic. So you're taking a messy pile of images and instantly creating standardized scientific records.
Exactly.
Okay, let's move from cleaning up data to predicting the future. This is where things get really interesting. For years, if you wanted to map species distribution, you needed deep knowledge of geographic information systems, GIS.
A huge bottleneck.
Right. So the Species Mapper app is designed to just get rid of that barrier.
It really levels the analytical playing field. The mapper handles all the heavy lifting in the background. The user just uploads their database, the nice clean data they just made, as a CSV or an Excel file.
And then?
And then, in the web app, they can view details, toggle filters, and the app automatically does all the stuff that used to require a GIS expert. Spatial projection, heat mapping, all of it.
And the final product, what comes out?
A full high-resolution scientific image. A map that's ready for publication in a peer-reviewed journal or to share on social media to alert the public.
So what used to be a $5,000 software license and days of work is now
a 3-click automated process.
Okay, now let's get into predictive analysis with the ocean drift tool. This isn't just looking backwards, this is forecasting.
Yes, this is operational science. It tackles the growing problem of jellyfish blooms, which, impact tourism, aquaculture, everything.
So how does it work?
The tool takes input on current jellyfish populations, where they are, how dense. Then it pulls in real-time satellite data and oceanic models.
To predict where the currents and wind will move them.
For the next 5 days.
5 days. That's a really meaningful window for action. What are the benefits of that forecast?
They're immediate. Proactive beach safety alerts. Aquaculture farms can move their assets. Tourism boards can plan. It turns live environmental data into a public safety tool.
That's a huge leap in preparedness. And if we're talking about advanced monitoring, the acoustic analysis tools sound just as powerful. Tell us about the work with golden jackals.
Right. So acoustic monitoring is essential for animals that are secretive or nocturnal. These tools analyze field recordings and automatically create visuals like histograms and waveforms.
Standard stuff for ecologists.
Standard stuff. But the micro app goes way beyond just logging that a jackal was there.
How much further can it go with just audio?
It provides forensic level detail. The AI is trained to distinguish individual voices based on, subtle variations in their calls.
And from a single recording with a whole chorus of calls.
The tool can detect exactly how many different unique individuals are calling in that one audio file.
You're kidding me.
And not only that, it then exports each unique jackal's call as a separate clip. And it tells you the exact timestamp in the original file where each unique call happens.
So you go from just a jackal was here to...
We had 3 unique individuals calling, 2 males, 1 female, and they were active between the 1:15 and 2-minute mark.
That's next level insight. It dramatically increases the accuracy of population monitoring without ever touching an animal.
Exactly.
Okay, let's put this all in context, because this isn't some theoretical research locked in a lab.
No, this is all operational right now.
We learned that Merman Conservation Expeditions, the group behind all these tools, they created and deployed this entire suite, the renamer, the mappers, the acoustic tools, all of them, in just the last 3 months.
And here's the disruptive point. Accessibility.
Right.
Merman operates as a nonprofit. Every single one of these tools, which do things that used to cost thousands of dollars, is offered for free.
For free to everyone.
To conservationists, citizen scientists, NGOs, researchers, globally.
That just completely breaks the old model.
It disrupts the model where insights were restricted to those who could afford expensive software. Now, the people on the front lines, the ones with zero budget but critical local knowledge, can deploy world-class data analysis instantly.
So the synthesis here is pretty clear. Accessible tech, developed fast and deployed freely. It's the engine for more accurate data, faster reporting, and stronger ecological knowledge.
It removes every financial and educational barrier.
And what's really compelling is the efficiency, because the AI is handling all the heavy, tedious work.
All the boring stuff that used to consume a researcher's time.
It frees up the humans to focus entirely on the irreplaceable parts of conservation: exploration, discovery, and actual protection. So what does this all mean for you? The core takeaway is that the tedious parts of conservation are now being delegated to these smart little apps. This frees up the human experts, the citizen scientists, everyone, to apply their unique intellect and passion to the real challenge of saving species. We're moving from data entry to actual impact.
And if this is what agile teams can build today, I mean, tools with forensic acoustic detail and 5-day ocean forecasts, all available for free. Just think about what the next 5 years will bring.
As the tech gets even smaller, faster, more integrated,
That's the accelerating scale of change we're watching unfold right now.
it's a future being built now, not later. A future that uses technology to empower people. Let's move forward and shape it together. Thank you for diving deep with us.